we're going to talk about controlling fan arrays, which is, we get that question all the time. And Mark and I and a couple other folks from Nortek Air Solutions did a presentation online a few months ago, fan array mythbusters, we called it. And we got tons of questions in the chat about how do you control fan arrays? What's the best way? What are the different options? So we figured we would definitely bring Mark back and have a separate conversation surrounding that. So so please, if you're watching, throw out some questions here. We're going to make this more conversational. We don't want it to be real slide heavy. So we'd love to have your comments on the presentation. And I'm going to go ahead and run the slides. And Mark, you just tell me when you want me to advance, and I'll go ahead and do one of these deals here. So go for it.
All right. Thanks, Tony. Appreciate you having me on. Thanks, everybody, for joining. Again, we're going to go through some options we have for controlling fan arrays. We're going to kind of start at the basics as far as, what you need to include kind of as a standard package, and then some different packages that you can use on your fan systems. Go ahead and go to the next slide here, Tony. So fan arrays, obviously we're using multiple fans. We have multiple motors. So it presents some challenges on, education on what we've seen, previously on older technology. So we're going to go through a couple things here today. And again, as Tony mentioned, let's talk about it. If you guys have questions, feel free to jump in. Like I said, we're not going to have a lot of slide heavy information, more of a discussion and what we see here. So a couple things we're going to talk about right off the bat is overload protection. Since we have multiple motors, we do have to make sure those motors and branch circuits are protected with overload protection. And then we're going to talk about some of the VFD packages that we see a lot that are most common in our industry and custom HVAC. So we're going to jump right in here, go through this. Again, if you guys have questions, feel free to chime in. We'll do our best.
Hey, Mark, real quick. I do have a quick question.
Sure.
For those who are not watching, because some people, we have a lot of folks watching who are maybe new to the industry and might not even know what a fan array is. So can we start back and pull it back to basics for the engineers who might be watching, who are just coming out of school or maybe just a year and never worked with custom units before?
Yeah, absolutely. So fan array, pretty self-explanatory array of fans. So if you look at that picture there, and again, if you can't see, if you're just listening in, basically it's a bank of multiple fans that drives your fan system inside your custom HVAC. So it could be as few as 2 fans or as many as 30 plus fans, depending on the size of your air unit. We see a little bit of everything. So again, you got multiple fans, multiple motors controlling the airstream and airflow and static pressure within your unit. So that's kind of just a plain vanilla fan array description.
So what would be the advantage over if you're not familiar with fan arrays?
Right.
Like I'm looking at this thing going, man, wouldn't one big fan be better and easier and more efficient and less maintenance? So why would someone what are the typical reasons someone would use a fan array?
So there's a lot of benefits for fan arrays. One, first and foremost, is efficiency and reducing system effect. So with a fan array system, you get much better even air profile throughout your air unit. So it helps really make all of your components more efficient just by air profile and reducing that system effect. You'll get better airflow across your coils, across your filters, et cetera, et cetera. And then
with one big fan, if let's say you had one big fan in that picture there,
that's right,
you'd have a concentrated blast of velocity kind of in the center or wherever the fan discharges. If there's a coil downstream of that, you're going to get the concentrated velocity and airflow in the one spot of the coil versus this, which provides an even envelope.
Yeah, exactly.
Of air. What do you call it? A piston of air that moves?
We call it an even piston of air is what we like to say. So kind of as you're describing there, more traditional, larger fans, you get a higher velocity around the intake. And then, of course, the discharge, depending on what type of fan, it can either have higher velocities outside of your airflow or centered in your airflow. So when you even
airflow and the outlet, if you've got filters, you can have filters on either side of a fan, right? So if you've got that or the coil on either side of the fan, okay, gotcha.
Correct. Yeah. And so that's kind of just the system efficiency. Typically, you're using smaller fans; they're more efficient. Speaking on Nortek, we balance these fans to a very tight clean room tolerance, which reduces vibration, which can cause excessive heat and motor failure. etc. And then, of course, redundancy. So having multiple fans allows you to
Mm-hmm.
build in redundancy. So if you happen to lose any part of that system, whether it's the electrical component or the mechanical component, you can design that system around having redundancy built in since you're in a multiple fan motor application.
Yeah,
And
and it's
then
easier to change
that's right.
7.5 horsepower fan than a 100 horsepower fan, right?
Absolutely. So ease of maintenance is kind of where I
Yeah.
was going next. So they're much smaller fan and motor combinations. So two people can easily change out one of these if you had to, versus having to rent lifting equipment and changing out a 50 horsepower motor that may weigh 12 or 1,500 pounds and taking apart
Mm-hmm.
half of your unit, etc. Whereas these typically a couple people can change these out typically through the standard access doors that you have already included in your system here. So
Right.
so
Okay.
that's a few, right off the bat, your benefits of getting those. Also inherently with the better airflow, you can reduce footprint typically on your unit sizing, of course, which is important. Whether it's replacement type units, we also do see this a lot in retrofit type applications, as well as new construction. Saving footprint for other things on the
Mm-hmm.
building is important as well. So
I know we're working on several projects here in our local area, and I'm sure throughout Insight as well, but for retrofits, because of the capability to, if you've got an existing air handler and you got a really old unit, one big fan, you could chop that up, remove it, and then you could really literally wheel these in sections or cubes, 2 or 3 foot doors. Is that right? And then just pile them together, stack them together.
that's right. Yep, we can help design systems that'll fit existing casing. We see it a lot in times in built-up type applications, basement type units where they have old vane axial fans or large um, traditional type fans,
Mm-hmm.
where you cut them out of there, put these in. You have much more efficient. A lot of time we can match connected horsepower loads, even reusing electrical equipment. So there's a lot of options there. Then you get everything, all the benefits that you get with fan array systems when you do something like that. So,
And here's a loaded question for you.
Mhm.
So, what's the ideal number of fans for every CFM and every application?
we'll have to make this a longer broadcast. So that's
It
a good question.
depends. We've had the "it depends" answer many times today.
It
So,
really comes up a lot, right? So it does depend. It really depends on what you're after, what's your design. If you're after redundancy, if you're after lowest sound output, sound's another thing we didn't really touch on. But if you got a sound critical application, we can really dial in those selections. If you're trying to reduce your amp rating, amp draws,
right.
again, a lot of it depends on your CFM and static loads, plus the available space for your fans.
Excellent. Okay, so if I'll move on to the next slide, but just to pre-frame it. So in the custom world, when you're, as a rep, I would get this question all the time. Okay, I don't know how many fans are on there. 1, 2, 3, 4, 5, 7. Is it 21 fans? I don't know. 3 times something. I can't add it up that quick when I'm online. But so how do I control these? Do I put one, Mr. Tony, do I put one big VFD and ramp them up and down, or do I turn things on and off, or do I, have one VFD per fan? So these are the kind of questions we would get as a rep, and I'm sure a lot of people watching have those questions, and that's what's gonna ideal. Thank you, McQuinn. And Paul says multiple fans at lower speeds will use less energy than one fan at higher speeds. So that's the question, and that's the point of this discussion. So hopefully you'll leave here with a little bit of an understanding, like, okay, if I have 6 fans, I have these kind of options to play around with. So
Sure.
great. I'll go to the next slide here, if that's okay.
Yeah, go ahead.
All right.
All right, so first thing, and we'll get into the slides here, we'll talk about motor overload protection. Since we do have multiple motors, we do need to make sure that we have overload protection for each motor, depending on what your control package is. And then we have simple options here. We're going to kind of go through more of the common packages that we see typically a lot. Just a standard VFD, VFDs with bypass, redundant VFD panels, and multi-drive VFD panels. And keep in mind as we go through this, guys, you can customize electrical components and packages just like you can a unit. So you're going to have, if you have very special needs, we can always look at stuff like that as well. So depending on, what you're trying to do with your building control systems and those kinds of things. So just keep that in mind as well. I'm going to touch base on kind of the standard packages we see a lot, but know that there's always customization within each of these as well. So,
and each motor needs overload protection always per code. That's not just a option, right? You can't have one protection for all the motors, or can you?
Absolutely. You need overload protection for the motors. And really what we see, and as we get in the packages, I'll explain that a little bit more, but you've got to have overload protection for each motor. If it's on a single drive, so if it's on a single VFD, it only sees the connected load. So if you have a motor that is drawing a higher current, no matter what the issue is with that motor, if it's on a single drive, it can't always sense that, and you can damage your motors, your components, your electrical components as well. So, of course, we have options for motor overload protection, but that's going to be pretty much a requirement. Now, it can be done in different ways, of course, but we're going to go over kind of what our standard packages that we see a lot, and what you might see out in the field as well. So,
great.
All right, so if you want to pop over to the next slide, Tony. So what we have here is kind of a standard overload package. If you look at the screen here, if you'll advance one more, it'll draw a leader there.
There you go.
There we go. So this is kind of a quick example of a standalone motor overload panel. So again, as I was speaking there, if you have multiple fans wired out to a single VFD, that single VFD can only sense a connected load. So it can't always sense individual motor current draws. So this is kind of an example here of just a standard factory overload panel. So inside this box, you have basically, let's call it a circuit breaker that each fan is wired to, that will act as that overload protection for each individual motor. So basically this package is kind of a basic, simple package. It's got the circuit breakers inside the panel. At the factory, we would wire the fans out to this, and then we have overload protection for each motor. Now, that is just standalone overload protection. This can always be provided inside of custom electrical panels. Kind of as I mentioned there at the beginning, we can customize, and as well as VFD manufacturers, they have the ability to customize their panels as well. But this would be kind of just a standard setup. You can see there we've got individual overloads for each motor. Each motor is going to be wired out to those overloads so that they have protection. So any questions on this kind of package? You seen anything?
Yeah, if anybody has any questions, please put them in the chat. So is there times where you, as a custom manufacturer, and I believe I know the answer to this, you just ship the motors without any type of protection or circuit breakers, disconnects, and then they're installed in the field?
So we typically would not do anything that would require field installation. The only package that we would ship out to the field without factory overload protection would be if you had an application where you had a drive per motor. So you're going to have a multi-drive type package, or a field installed VFD package that included overload protection. So in that case specifically, we would want to review that. We could wire out to a terminal panel or junction box, which I'm going to show on our next slide here if you want to go ahead and advance.
There you go.
Yep, so you can see there's kind of a standard junction box or terminal panels. Those do not provide overload protection. Now, you would typically see that wiring if you had a single fan motor. On fan arrays, typically you're going to only see that, again, if you had field installed motor overload protection. And from the factory, we're going to want to confirm, what type of packages are going to be installed. Unfortunately, due to supply chain and those kinds of things, we see that a little bit more these days. But at the bare minimum, we typically always want to provide that overload protection at the factory.
Okay, so this photo here, fan array motor overload protection, and this photo here, are we looking at just different ways to do the same thing?
So so in the slide that you have pulled up there, that's a junction box or terminal panel. So again, that's not going to provide overload protection. That's only going to be used to terminate the wiring
Oh, I see. I
for
got you.
field installed applications.
I
So
missed that part. Okay.
yep, not a problem. Just
Excellent.
wanted to show an example of what that looked like versus
Yeah, for
overload
sure.
protection. So
Yeah, we did get a question. It was answered by somebody else, but we could throw it out there to make sure everyone hears it. So is this upstream or downstream of the single VFD, the motor overload protection, I believe?
So the overload panel, the overload protection will be on the upstream side. So if the fan wiring goes, we wire the fan motors to the overloads, then those will be wired to a branch circuit, which will accept power from the VFD. So you
So
basically
between the drive and the incoming power goes into the drive, leaves the drive, goes into motor overload, then into the motor.
correct. Yeah.
Gotcha. So upstream or downstream, depending on which way you're flowing in your head. Yeah.
Yeah,
Okay.
and so typically on a standard setup, if you got a single drive, you're going to have power coming into the drive. Then it's typically a 3-wire connection out to your overload package, which would be more of our standard type package that we use. And then all of the wiring from your overloads to your motors, of course, is all done at the factory as well. So
excellent. Cool. Okay. And if you
all right,
guys
so go to
have
go to the next slide, unless we have any questions pop up. But I wanted to show here kind of a standard application where we've got a single VFD. So, typically these fan arrays, of course, are going to be run on VFDs, which are variable frequency drive. And so you're able to vary the speed of the motors by varying the input frequency. That's what the VFD does. So this allows you to turn up and down the fans on your unit, your system here. So kind of in a standard typical package. There's a lot of different VFD manufacturers. You'll see, I don't know how close you're looking here. We got Yaskawa and ABB are pretty typical, but there's a lot of VFD manufacturers. So this is kind of a typical package you see on your right there, where you've got the fans wired out to an overload panel, and then we've got a connected to a single VFD. So in this case, you're going to run all of those fans, whether you had 4 fans or 6 fans or 8 fans. They're all going to be run off a single VFD here. So
one VFD ramps them all up or all down, depending on what we're doing.
That's correct. So
controlling the static pressure or whatever. Okay.
Exactly. Whether you're controlling static pressure or airflow, depending on how you're hooking into your building automation system.
And what's that box on top of the VFD? Is that a bypass, or is that is that part of the VFD?
So that's a configure drive. It could have a bypass, or it could just be a custom size. And we'll talk about bypass here when we get into the next slide. But as just kind of a basic generic package, you got a single VFD with overload protection either into the electrical panel or a separate box as shown on the right. So again,
how many? Go ahead. I'm sorry.
Well, no, I was just going to reiterate the fact that, we're providing overload protection for those motors, whether you've got, again, if 2, 4, 6, 8, however many fans running on a single drive, you've got to have overload protection there. So
how many units, fan arrays do you ship without VFDs on them, or that end up with no VFDs at all whatsoever? Like either you don't put it on there, or they're installed in the field. It's pretty rare to have one without a VFD, isn't it?
So typically in the past, we would definitely see more VFDs. Again, with some of the challenges because of supply chain, we're seeing more and more VFDs be field installed just because of lead times. So you got a certain time frame to get your unit installed in the space. And of course, the VFD lead times a lot of times are farther out than that.
Mm-hmm.
So and that's
seems
where
to be an industry issue with the VFDs.
Yeah, it's industry wide. In my experience right now, it's probably about 50-50. Half the units are going out with VFDs, half without. Again, it really just depends on the market and what you're trying to accomplish there. We typically are going to wire out to an overload panel, and that's why we have that ability to make that a separate panel. So if you were going to, mount a VFD, a single drive as shown here, you could mount it on the unit. Sometimes they'll be wall mounted. It really, again, depends on, what your space, what your installation is.
Gotcha. So the motor overload protection was the first thing we looked at. Then this would be the addition of one VFD for all the fan motors. So we did get a question here, and we talked about this a lot on the Mythbusters event. And this question comes up all the time. So Nick Maffeo, I hope I'm saying that right. Why not ECM motors instead of VFDs?
So ECM motors are definitely an option. We certainly can use ECM motors. We have offerings for those as well. The biggest issue with ECM motors right now, again, is lead times. So there's certainly applications where ECM motors make sense. They kind of, data center type applications, we see them a lot. Office buildings, lower static pressure applications. But right now we're seeing, just as an industry, lead times on ECM motors well over a year into a year and a half just to receive those from the suppliers. So
you got to really want them right now. Yeah,
you do. So, and then again, it's part of that supply chain issue. ECM is certainly an option. So since we're on that topic, ECM, again, you'd have the fan motor is built in. It has the speed control. Basically, it's a VFD in the motor, just kind of as a simple definition. You still would have overload protection requirements with ECM. So kind of in a standard ECM package would be very similar to that overload panel package. We're going to have individual overloads.
The original, yeah. So if people are new and they don't know what that is, it has a speed control built right into the motor. It looks a little bit different. They're kind of flatter, more like a pancake shaped design. You send the signal directly to the motor itself to change the speed instead of having a separate VFD. And I think, you correct me if I'm wrong. So taking the lead time out of the equation, all in all, apples to apples, why would someone choose? Is there a couple of reasons why someone would choose ECM? Is it more,
some of the so some of the benefits of ECM, first off, right off the bat, you don't have a larger separate control panel. So if you were comparing induction motors versus ECM, you would want to have a multiple VFD package where you had a drive per fan motor, which would be equivalent to an ECM package. So you're going to have a much larger VFD package enclosure. So that could be an issue if you had, tight installation requirements. Obviously, it's going to take up more footprint on the unit or wall or wherever that drive package is mounted. ECM typically is going to be more efficient in turn down modes. So if you had, turn down conditions, you're going to save a little efficiency operating those. If you're turning those down 50%, for instance, if you had a night turn down mode, say for like an office building, where you're going to have certain turn down conditions, definitely more efficient. They're a little bit more limited on sizes of the motors that we can get and some of the fan applications. So if you have a higher CFM, higher static, we're a little bit limited on what we can use ECM on. But so lower static pressure applications, typically where they'd be more prevalent, again, data center type applications, office buildings. We started seeing them in schools and such like that, where you're going to have some turn down conditions.
Hospital with a, final filter bank, couple coils, pre-filters, probably not a best in the high static applications for.
That's right. Once you start getting into that upper static, you got HEPA filters, multiple layers of filtration. Your static pressures are getting well above 5 inches of total static. Typically, you're going to be pushed back into induction motor options.
Gotcha. Okay, a couple other questions we had here. So Ahmad is asking, how is the installation different if the unit is mounted outdoors? And I'm assuming we're talking about the panels, the VFD and the panels.
Yep, so there's different NEMA ratings for these enclosures. So again, keep in mind, within our options, we can do fully customized cabinets. All VFD manufacturers typically are going to have different NEMA indoor rating enclosures and outdoor rated enclosures. Examples being NEMA 3R, NEMA 4 for outdoor rated, NEMA 1, NEMA 12 for indoor rated type enclosures. And then also, if they are going to be unit mounted, we can certainly provide, outdoor rated vestibules and compartments to mount these pieces of equipment in as well. So if you have the space footprint on outdoor units, we certainly can provide service vestibules, add-on type compartments that can seal and ventilate that equipment as well, to make it weatherproof. So there's a lot of options depending on what your applications are. So
right. So it's not an issue. We just need to know. It's good to know that ahead of time before the unit's built.
As long as we
is what I
know,
understand.
you don't want to end up with indoor rated enclosures on outdoor equipment. That doesn't end well usually.
I haven't in the while I've been doing this, I haven't had that happen yet. But every year something happens, and I'm like, I never would have thought that would happen. But so much to learn. Okay, thank you, Ahmad, for the question, and thank you, Mark. We have a few more questions here, so please keep the questions coming. This is a lot more fun having the conversations, that's for sure. So Clint Hardy, so that's a good question. So we were talking about 1 year lead times for ECM motors. How does that compare to VFD lead times?
Yeah, so VFDs again differ, with the manufacturers. The VFDs we typically provide range anywhere from low 20s to mid 30s, and it really again goes back to what options you're looking for. So again, VFDs were the same. They went way out. We couldn't get them. They've kind of settled a little bit, so we are able to get drives again depending on specific models and options. We are still a little bit limited, but in much better shape than where we're at with ECMI options. So
yeah, so it's that whole, we were talking about this in the last presentation, the engineering trade-offs on every
oh yeah,
it's such a it depends question.
Yeah.
So that's really good information. We get a lot of questions on that, so thank you for answering that. And Richard H would like to know what your opinion is on the reliability of EC motors versus VFDs. Good question.
Yeah, good question. We haven't had again. We've been using induction and VFDs for a much longer time frame, so of course we have more of those out in the field running. But ECMI has been done very well for us as well. Even though we don't have as many out in the field running, we do have several applications where we use that. Multiple fan arrays that have been running, and as far as everything I know, they're very reliable. Just as you would for induction and VFDs. So,
yeah, I would say my experience with EC, VFD, and induction motors is they're all very, pretty reliable. When I first started, we were moving from inlet guide vanes. I don't know if anybody watching remembers those. Those are such a pain, man. Oh my gosh,
yeah.
brutal. God forbid you had to replace one or fix one. But moving to VFDs, it was real nervous, because it was new and they were glitchy at the time. But now it's not even a thing. I mean, almost every unit we sell has a drive on it. So.
Yep.
Great. Okay. Any other questions? Please put them in the chat. We greatly appreciate the conversation. So, okay, need to go back to the slide here.
All right. So if you'll advance a couple times here, we'll pop into another option you have for the VFD control. Go one more here. So VFD with bypass. I think you brought up a drive on that last slide, asking if there was a bypass on that. So another option here is to purchase or provide a VFD with a bypass. So again, you're gonna be running a single VFD for these multiple fans. So again, you're going to use that single drive to vary the speed of those fans depending on what the load is calling for. But in both of these examples here, we have what's called a bypass. And basically a bypass, kind of as a simple definition, it's a motor starter that's built into that drive, which allows it to have full voltage basically across the line for control of the application. So in the event that you had a drive failure, it'll switch over to bypass and run across the line, across your voltage is in what we say across the line. So what that does, it allows your fan to run at 60 hertz speed. So if you had a VFD failure, depending on where you're running that drive, if it failed, switch over to bypass mode, you can run those motors at 60 hertz across the line. So this is another application. Again, it builds you in a little bit redundancy. Again, you're limited if you do have a drive failure to only going across a line. So it's going to run those fans at 60 hertz. So depending on where your design points are, you could either lose a little bit of airflow or static or gain some depending on, what that design is.
Yeah.
So this is another option. It's not quite as popular as what we've seen in the past, just with multi-drive applications and stuff, and we'll talk about that a little bit more. But it does give you a little bit of redundancy in your system if you were to have a drive failure on a single drive type application.
Yeah, we going back, like I was saying, when drives first came out, bypasses were pretty standard. Everybody wanted one because they weren't sure about this. But I tell you, I get nervous providing bypass because you're not always operating at 60 hertz,
right?
And the boxes, if it's a VAV system, your boxes might be shut, or who knows what's going on downstream. It may not even be designed to run at 60 hertz. You know what I'm saying? It might just be at a reduced airflow. So when, as a caution, if you're a designer, when you go into bypass, you're getting 100% of everything. So if the ductwork and system is not ready for that, that could cause some issues. I never personally had, that I know of, an issue with that happening, but I've always been, a little wary of that. So
that is one thing to keep in mind if you're designing around that. Certainly an option to give you some redundancy, but check your system and make sure, for Nortek Air Solutions, we can show you a design run at 60 hertz through our application software. So certainly can give you what the expectation would be if your drive did go into bypass mode.
That's a great. I'm glad you mentioned that, because I forgot about that aspect. Like, you can design it so if you do go into bypass, you're safe. Like, you ban the wheels and stuff like that. So fry the right fan. Great.
So that's an option. Yep. Go ahead. So no, go ahead.
No. Well, Eric had a question, and maybe you're going to get to this later. And if you are, that we could just wait for that. But it says, should you not have a bypass when you have one VFD per fan?
Yeah, you should not. Yeah. So, and we'll get into multi-drive. The one thing you don't want fans running different speeds. So you wouldn't want a scenario where you're running multiple drives, whether you're running a drive per fan or if you're running multiple drives, running multiple fans in that array. You wouldn't want a scenario where one drive failed, kicked into bypass, and now you have one or more fans running different speeds in that fan array. Can definitely cause some issues. So, and we'll talk about that. We're going to get down into multi-drive panels and talk about some of those options, but that's a good question. So the answer is yes, you definitely would not want bypass on a multiple drive application.
That would be a little
on your fan array,
a little scary. And Jimmy Hunt asks this question. Hello, Jimmy. Hope you're doing good in Greenville down there. Could you set up a new unit to run full speed with revisions to add VFDs when they're finally shipped?
So we do have some options there. So typically, if we're gonna run into a scenario like that, we're gonna work with our rep partners and such to have field installed type drives, whether they're furnished from the factory or not from the factory. So we typically can't fully run a unit without a drive. We do have some really in-depth custom options. It's some stuff we could look into for that, but typically we're not going to be able to completely run that system without a drive, whether it be factory installed or field installed. Excellent. I hope that answers your question. So,
good question. Good idea. Good comment. Thank you. Should I go to the next slide?
Let's go ahead and keep rolling here. So one option we do see still quite a bit is a redundant VFD panel. So we'll see this application a lot. If you've got a critical operation, hospital, healthcare, industrial type, manufacturing type applications even. So basically, a redundant VFD is going to have two drives in a single control panel. If we got one drive size to run the entire fan array, if the event that there is a drive failure, there's automatic switch gear in that will switch over to the secondary backup drive. So, you've got one drive, again, running the full array with a backup drive that's basically identical. So if you did have a drive failure, it'll automatically switch over to your backup drive, and you're not going to have issues where you would maybe with a bypass where you're going to lose airflow or possibly gain airflow running straight across the line. So we do see these packages.
This would be in lieu of having you wouldn't even need a bypass for something like that.
That's right. So this gives you redundancy. These would, again, not have a bypass. Again, this is kind of just a typical panel setup. You're still going to have individual overload protection, and then you can customize this drive, of course. But the kind of bare meat and potatoes, you're going to have two full-size drives for your fan array with automatic switch gear that'll switch over to your secondary drive if there is a failure.
I like it. Cool.
So again, we see that a lot, just again, depending on your application. But this would give you full redundancy on your system with your fan array so that you would have electrical redundancy here in case of a drive failure.
Excellent.
All right, we'll keep rolling here. So
Yeah.
multi-drive. So we did have a
This is
question.
great stuff, by the way. Thank you.
Yeah, good. Just had the question on the bypass. So again, this is probably one of our most popular options we see a lot in today's designs is actually having what we call multi-drive VFD panels. So these two applications here kind of show where you've got one VFD per fan motor in your fan array. So this would have an individual VFD size for each motor in the fan array. So in this type of application, since you have one VFD per motor, you would not need secondary overload protection. So the drive itself is going to be the overload protection in this case. So again, you're going to run these fans they're all going to be programmed to run at the same speed, but you're going to have redundancy again built in since you have multiple fans, multiple drives. Again, you can customize this a lot. So, other manufacturers have different packages. Nortek Air Solutions has customization, customized packages that have some patented options as well, depending on, what options you're wanting to do and control your fan array system. But this allows you to have one drive per motor. Again, takes care of your overload protection, and now you have redundancy built in as well.
So you don't need the overload. So you only need the overload when there's one drive and there's multiple fan motors, correct?
That's correct. And so, again, depending on your application, this multi-drive VFD panel, again, we've got one drive per fan motor, but we have seen applications where, let's say you had a 9-fan array, but you wanted to run 3 VFDs off of that array. So instead of having one drive per fan motor, you've got drives size to handle 3 motors. And so in that application, you would have an overload protection requirement. And then you can, depending on how you do the wiring, whether it's at the factory or field or in a custom panel, you could provide, a lot of different options on how you want to control that. But these are kind of the standard packages we see a lot. Keep in mind, depending on what your requirements are, we can fully customize packages, for your needs.
Right. So I get it right in my brain. So one VFD controlling, I'm just going to use 4 fans because it's simpler to have the discussion. So one VFD on 4 fans, you've got one point of control and all the fans are coming on, ramping up and down simultaneously.
Correct.
Right, at the same time. So, and then if you've got one VFD per motor, and you've got 4 fans, do I ramp them all up and down? Do you ever get in a situation where you have one off and, I'm kind of pitching to this question. I think I know the answer to it, but one off and 3 ramping up and down. And how does air not bypass through the one that's off and stuff like that? So.
Yep. So there are options there. So typically if you just have a standard multi-drive application, you're going to turn up and down those fans at the same speed, just like you
all
would
of them running at the same
drive.
speed.
That's right.
Okay.
So now we do have packages, Nortek specifically. We provide backdraft dampers that are standard on our fans where you have multiple fans in our fan array system. We also have patented control applications where you can actually turn on and off fans and change the speed to keep them running most efficiently, which is called our optimization packages. Again, those are Nortek specific that are patented options. And those typically are going to run off of duct static pressure or airflow, depending on what your building automation systems are. So again, it's kind of one of those depends answers, right? But when you have a multi-drive, if you do lose a fan, for instance, we always have those backdraft dampers. So you close off that fan cell so you're not recirculating air. And then you can speed those other fans up to give you more airflow if required. And then again, we always have factory specific options, specifically with Nortek Air Solutions that are patented where you can cycle fans on and off and change speed to keep them running more efficient depending on your application. So,
yeah. And then make sure if you're a designer and you're working on a fan array, it has some sort of anti-short circuit capabilities like backdraft dampers, because if one does go down, especially if you only got like 4 fans, it could cause a significant short circuiting of the air. But yeah, do you ever see in that same scenario, so if you have 4 fans, do you ever see 2 VFDs, one on 2 fans, one on the other 2? And what's your thoughts on that?
Yep, occasionally we see that. If you want to have some flexibility in how you control without getting, really customized in your electrical panel, we'll see occasionally running half the fan arrays on one drive and half the fan motors on the second drive. And that would allow you some flexibility to be able to shut half the fans off in any case if that was something that you wanted to design in. It also gives you some redundancy as well. If you lost one of the drives, you would still be able to control half of the other fans in your system as well. And then again,
Excellent.
we can customize those packages. Specifically when we see packages like that, typically we're going to kind of checkerboard wire those fans so you get a little better air profile again. Going back to our previous comments about having more of an even piston of air through your unit gives you that best performance.
Right. So if you got 9 fans, you don't want to shut off, a third on the side here, right? You want to kind of spread it around a little bit, checkerboard.
That's right. Yep. So you can try to keep that airflow path even again through your air unit. So